All right, for number 7, you're going to name each quadrilateral parallelogram as a rectangle, rhombus, or square for each of the statement that is always true. Here is a Venn diagram that allows us to see a couple of things. Okay, so which one is all equal angular? So equal angular means all equals all the same sides. So that one we look like it is a rectangle would be one of them. And because you notice for the rectangle, all the angles here are 90 degrees. So we could say the rectangle is equal angular. And since it's a rectangle, we can also say it's also a square. So for those, rectangle and a square, it is equal angular. Okay. B, it's equal angular and equilateral. Equilateral means the same side. All right, so let me write equal angular means same angles. Okay, and then you want to know this is same angle and same sides. And the only one for that one is going to be your square. Okay, it's a more specific version of A. It requires it having both the same angle and the same sides. Next, we want to look at the diagonals that are perpendicular. And for that one, we know that that is a rhombus. Okay. And since it's a rhombus, it also is a square because a square shares that property of the diagonals being perpendicular with a rhombus. Next, it says opposite sides are congruent. Well, that looks like that is true for a rhombus, a square, a rectangle, and not a parallelogram, right? Because parallelogram includes a kite. So we can include the 3 ones under the parallelogram. That is a rhombus, a square, and a rectangle. Okay, the opposite sides are congruent. Next, the diagonals bisect each other. So that means it creates equal pieces. And that is a property of the parallelogram. That is just a definition of the parallelogram. The diagonals bisect each other. Next, the diagonals bisect opposite angles. Okay, so let's see here. And the only one that the diagonals bisect each other, that is a very unique property of the rhombus. Okay. All right, that just means the diagonals bisect and creates opposite angles there. All right, so there you go. These are all the statements for the shapes that are always true.